Basically here we're going to talk about some security best practices now. Everything in this talk is basically advisory. Linaro has a lot of different members who all have their own security policies that folks should follow. So nothing in here should override your own company's security practices. But at the same time, there's a lot of folks I know who are new to open source or even just working outside of their firewall. So kind of wanted to provide a baseline of best practices that folks can try to follow to be a little more smart about things. So why is this important? So Linaro is an organization of technical excellence. Now this is sort of the a platitude that executives like to say, but it's true. We're not a clothing design company. We are a technical company. Everyone's gone to school and learned how to design software correctly. We work on very difficult technical problems successfully, and so relative to all of the organizations out there, we should be able to handle managing data securely. So whether it's NDA information from members, just information that you want to share within your team but not the world, or even very sensitive HR data, things like medical information that you really don't want widespread, we should all be able to handle these appropriately. Now, that said, why is this very important? So this is a slide I stole from Greg Crow-Hartman in one of his talks that he was talking about how everything is awesome in the Linux world. And it's true, Linux is everywhere. We've got it on, desktops, laptops, tablets, routers, phones, watches, cars, aircraft control. It's really quite a bit. It's really everywhere, and that's great. But mistakes really happen, and I guess the Heartbleed issue, while not Linux specific with SSL or OpenSSL, it kind of shows the scope of impact that security problems can have. Basically, in this case, it required, or basically allowed user data and passwords to be vulnerable on servers around the world. And hopefully, everybody's gone out and changed their passwords since then. Similarly, we have these phones, and they contain all sorts of private information that we don't want to share with the world. Email, texts, your location, that sort of thing. But for the most part, these things are, rarely updated. So when there is a security issue, these can be very long-standing and can cause problems for quite a while. And it sort of seems like a week doesn't go by without some company getting hacked. And it really does have a big impact on these businesses as well as their consumers or customers. And I guess it's not just somebody sticking it to the man to some extent, because this really does have an impact at a lower level. It's not something where parents who are having trouble getting a home loan because they're dealing with identity fraud, because they bought diapers somewhere. That's kind of a big impact that I think need to take seriously. And it's not just bad actors out there on the net. There's also, countries are hacking other countries. Some countries are hacking just everybody. And so Linaro likes to advertise that it's a major contributor to Linux. And it's very true. The work that we do goes out to hundreds of millions, if not billions, of devices. And so if someone's looking for a vector to attack the Linux kernel or the Linux ecosystem, us and our work are potential targets. And so I think it's, this is a very sobering thought, hopefully. And I think it's important that we make sure we do our due diligence. Now, the disclaimer here is that nothing, is really going to stop somebody who's really targeting you in particular. It doesn't matter how good the doors or how good the locks on your doors are. Somebody can break a window to get into your house. But there's also that story that two folks go walking out in the woods and they come across this big brown bear and starts charging towards them. And one of them bends down to tie his shoes. And the other says, you can't outrun the bear. And he said, I don't have to outrun the bear, I just have to outrun you. And so likewise, I think it's important that we aren't the easy target out there. We don't want to paint a target on our backs. So with that introduction, here's kind of the overview of what we're going to cover. At first, it's basically basic tips everybody should know. this is stuff that, somewhat remedial, but also things that are applicable to really everyone. Hopefully, you can take it home, tell your parents, I don't know. And then we'll also cover some advanced topics for developers. So first, the tips for everyone. Now, everyone's dealt with password rules. Every website has a different set of them sometimes. But the one important password rule is never to reuse passwords. Basically, you wouldn't trust me with your bank password, but if you reuse passwords across websites, you can basically trust you might be trusting your bank password to the New York Times. And anytime you provide that password, you're trusting that that other party keeps that password securely. And repeatedly, they've been found that companies do not manage their passwords well. And even if they do manage their passwords well, sometimes those password files get leaked. And it's possible right now that every 8-character password the hashes for those can be generated in a day. And so even if they're securely managed, it's possible that those can be reversed. So I really recommend probably having a 16-character minimum. At that point, passwords don't really work. You really need to have passphrases. So think, 4 random words, throw them together, that sort of thing. Now, of course, you have to do this for 30 to 80 accounts that you have on the web. And this really gets to be almost impossible. Passwords are really terrible technology, and I'm surprised that we're still using them. So the first step to kind of improve things a little bit here is two-factor authentication. Basically, this basically means in order to access your account, you need your password as well as a time-limited PIN. These PINs are provided usually via SMS. You can also get them through Google Authenticator or fancier versions with the RSA tokens or YubiKeys. This basically means that for someone to compromise your account, they need to have your password as well as your phone, which is kind of that same something and something you have requirement that banks use for ATM cards, that sort of thing. So this is really improved security fairly well, and I really would recommend that it's fairly easy. There's a link here. Go set it up. I'm kind of curious out of the room here who actually has already set this up on their Linaro accounts. So half. That's pretty good. The next step, I recommend password managers. Basically, this is something where you're keeping all of your passwords in a file that's then encrypted with a master password. This can be as simple as a file on your hard drive that you encrypt, or some sort of third-party plugin that you use with your browser. Basically allows you to remember one password and access everything, and this really does allow you to have random passwords for every account. I don't know how you would do it otherwise. Now, the other nice feature with this is it manages to keep a list of what sites you have accounts on. So the next time something like a Heartbleed style event happens and you need to go through and actually cycle passwords, it can be done because you have this list that you can go through. You don't have to kind of go, oh, I think maybe I have a site. Maybe I use that site or not. I don't remember. Personally, the other item here was, so most browsers have a password manager built in. Unfortunately, in the past, they didn't manage to store the passwords very securely, so that led to websites often requesting that the browser not save the password for their site, and most browsers comply with that. This apparently is being changed, but this basically means that it isn't useful for storing all of your passphrases. So third-party tools sometimes are a little more effective, at least for now. Personally, I like LastPass, but there's KeePass, 1Password, etc. that I suggest you kind of look into. One important gotcha with password managers is that your email is really it's your identity on the network, and so it's the only way that you can basically reset your accounts. Should that password list get lost or corrupted, or maybe you forget your master key, and especially for free email services, if you aren't able to get access to your email, then you're really unable to reset all of your passwords. At that point, you might as well just give up and move to Nevada and start your life over. So it's one of those things where I really recommend using a strong and memorable passphrase along with two-factor authentication for personal email, and then use a password manager for everything else. So this next item is kind of the most vague, but it's also one of the more important ones. Basically, to keep your system secure, this is sort of standard stuff, but just to go through it, it's make sure you're running a current supported distro. I really recommend using disk encryption on laptops in case they walk off. you want to make sure you have a local firewall enabled. I have GU, FW makes it really easy on Ubuntu. Just you can go in and block everything. It's advised to be intentional with the applications you run. So, obviously, for the work that you do, you're going to need various applications, but if you can minimize it to just the smallest set possible, that's kind of the best plan. I'd avoid things like Flash and Java plugins that have a history of their security problems. Also things like instant messenger apps or video players that take information from the network. Those are all potentially vulnerable. Also, it's important to make sure that the things that you run have active developers behind them and who are responsive to security issues. Things like the browsers are usually very good at that, but maybe your ancient IRC client might not be. And of course, don't surf sketchy sites from your workbox. That's just a bad idea. Now this slide is just kind of a reminder of unsecure communications and storage methods. Unencrypted email is not a secure method of communication, especially if it's going to a third party outside of Linaro. It's going to go across the network in the clear. Similarly for IRC, while you might be connecting to IRC servers using SSL, the servers themselves are not necessarily always trustworthy. We just found actually yesterday, I guess, Freenode was compromised. So anything that was said in even password-protected private channels could have been listened in on. Hangouts and Google Talk, Google Drive, Docs and Sheets, those also are technically not secure. Now the gotcha there is that this is a service that we're paying Google for, so it's sort of a similar level of trust that we have to have with things like our IT sysadmins. It's one of those things where it's for the most part, I think we can consider it trustworthy, but there may be situations where we need to take extra measures, and so just be kind of conscious of that. So next up are kind of more developer-oriented tips. First of which are SSH keys. So these are basically really useful. So they're basically asymmetric keys, so there's a private and public part. The nice part about this is you then distribute the public key to the servers that you want to access. And you don't have to worry about reusing keys because the public key doesn't disclose anything about the private key. They're also nice because they're usually 256 bytes or longer, which is much better than even a 16-character password as far as strength. So they're much better to use. As far as basic security with the SSH keys, first recommendation is just use SSH keys instead of passwords. If you have a server, disable password authentication. If you look in your var log auth log, there's usually a constant stream of people connecting and trying to brute force passwords. So I just recommend disabling password authentication for SSH. Also make sure that your keys are encrypted. Since you can't keep it in your head, you do have to keep them stored on disk somewhere, and so it's better, should your device get stolen, that they're encrypted. Also, I really recommend that you keep your keys on your physical devices, so basically things that you can put your hands on the keyboard. You don't really want to keep them on shared machines that other people can have access to, or things like virtual machines in the cloud. And similarly, I recommend only SSHing out from your physical devices. So this basically makes sure that you have a secure end-to-end communication. And so you don't want to SSH to one machine, then SSH to another, because if the first machine you SSH to is compromised, you would then potentially compromise the next machine that you hop to. So try to always make end-to-end. In the few cases where you have gateway machines or something like that, you can use SSH tunneling to try to go through to have a fully secured connection all the way through, but avoid hopping. Similarly, I recommend avoiding SSH agent forwarding. Basically, the main key here is for the kernel.org compromise in 2012. This is sort of the style that was how that machine got compromised, was by people SSHing to one machine and then another. So for SSH key management, personally, this is kind of more recommendations than anything that's very strict. I recommend using per device keys. A lot of people try to sync the same private key to a bunch of machines, but I think it's a little more flexible if you create a key per device, and then basically it allows you to kind of restrict the number of machines that maybe you can access from your laptop compared to your desktop. So if your laptop was to be stolen, then you'd have fewer machines that you have to deal with. The other nice part is it keeps you from having to remember that you maybe left a key on some old dusty laptop that was in the closet for a long time, and if you donated it or something like that. And so another important thing I think is to keep track of what machines that your keys can access. SSH doesn't make this very easy to do, so I kind of advise you do it manually. This is useful because it makes it very easy to basically audit those machines to make sure that the set of keys that are active on that machine are your current active keys, and you don't have a key for that old dusty laptop still in there. Also, it allows you to do nice things like you can write scripts that will rotate your keys fairly regularly, and this can be done in a very painless way, and you don't have to worry about accidentally locking out some other machine because you rotated the keys on one. I definitely think tools are needed here. If anybody wants an interesting side project, I'd really be excited to talk to somebody about this. So next up, securing your development system. This is really mostly the same information on the previous securing your system slide, but it kind of bears repeating. Really do stay current on your supported distro version. I used to work with a guy who ran like Fedora Core 3 for years and years and years, and it was one of those things where if you're going to pick, if you're someone who really doesn't like change, make sure you pick a long-term stable, Debian stable, RHEL style distro. Don't just kind of stop updating because you don't want to upgrade. Also, make sure you have your firewall enabled. Don't run incoming services on your dev machine. This is kind of an important rule that the Linux Foundation uses for their machines since the compromise of kernel.org, and this includes SSH. If possible, try to run as few network-connected apps as possible. Try to pull down to maybe just the browser and a terminal if you can. This really isn't practical, but at least it's something to aspire to. Again, avoid Flash, Java. IAM clients, particular Pigeon and libpurple, those are not audited for security. Another one is don't copy-paste commands from web browsers into shells. This is something where JavaScript can change data that's being copied before it's actually copied to, I can't remember the word now. But anyway, so before you get into your clipboard. And so always use an intermediary text document or something like that to paste into before you copy any sort of commands into a shell. And then again, don't surf sketchy sites. Finally, secure email. So finally we get to how to communicate securely. So GPG or PGP, these are basically useful tools for, again, asymmetric key encryption similar to SSH keys. Basically, you generate a public and a private key pair. You distribute the public key, and then folks are able to use that to encrypt email that only you can read, and you can also use your private key to sign your documents that you send out so that people can validate that it was really from you. Basically, once you've published your keys, you then need to kind of go around and get your keys signed. This allows to create kind of this web of trust, which is basically sort of a social network of trust. It's kind of a little complicated to do, but it allows basically for, once someone has signed a key, that if you trust them, you can then kind of trust the keys that they've signed. Doing this right is difficult, but I think it's really worth the effort. Hopefully this will improve. But the first kind of problem with secure email is it requires a non-webmail interface, so you can't use Gmail directly for this. As far as for pointers for tools here for things like Thunderbirds, there's the Enigmail add-on. Evolution, it's got integrated support. For Mutt, I say you can figure it out yourself. But I'm told actually it just works, but I'm a little skeptical. I think it depends on which oral tradition your config file is based on. And then for macOS users, there's GPGmail. As far as managing keys, dealing with signing keys, that sort of thing, Seahorse or KGPG is useful for GUI uses. And then even if you're just using the CLI, there's a tool Keychain, which helps you manage your SSH keys and your GPG keys. There's also some really cool hardware options out there, so the CryptoStick or the YubiKey Neo, if you want to get more advanced and deal with the fact that your keys can only live on a device that they can never be pulled out of. So how to get started with this, I really recommend folks go through and read some of the docs that I've linked here. Basically, the first step is to generate a key and publish it. Once that's done, you can print out your fingerprint for your key on business cards or just print it out on paper, bring them to these sorts of conferences and hand them out. Folks can then sign those keys that they find once they've gotten your fingerprints directly from you. But really more importantly, start signing your mail and using signatures in your Git tags. Consistency is kind of a more important thing than even just who trusts you, because so much of what we do on the internet, we deal with just emails anyway, and this allows us to make sure that we're at least dealing with the same person that we were dealing with, a month ago or 2 months ago. It's not necessarily the true identity part is I feel like less useful. So is this all really doable? It's sort of a big list of things. It starts to sound a lot like these corporate security policies that just get in the way of work. And to some extent, it depends. There's a book about how everybody commits 3 felonies a day, and it's just a matter that we're usually lucky enough not to get caught for systemic reasons or other. And so likewise, with security, I feel like you can't be perfect. You can't follow the rules all the time. But at the same time, I think it's important to be aware of the threats that are out there, try to work to minimize them, because we really don't want to paint a target on our back. Because there are real risks that we have to deal with. So hopefully that made you think a little bit about your process and give you some ideas for how to improve it. I've tried to set up a wiki page here to try to kind of get this all documented for folks who are joining Linaro. And I'd really love to hear feedback if folks have ideas for other steps to improve things. So yeah, please go check that out. And that's it. All right, thanks. I don't know, any questions or anything? I would suspect not, but go ahead. So using a virtual machine for what sessions? Browser sessions. So okay, so the idea here is using a virtual machine, I guess, to secure browsing so that if your browser were to get exploited, that you'd kind of limit the use. I think that's useful. I think it's often difficult enough to actually do, and I think a lot of people kind of don't want the extra performance penalty to really make that work. I know a lot of the browsers have tried what they can to start using containers and things like that to be able to isolate themselves as best they can, but yeah, I mean, I think it would be a great idea. I'm just not sure if it's a realistic thing to convince people to do. Yeah. Mm-hmm. Yeah. Yeah. Anything else? All righty. I guess everybody can head on to the next thing and then dinner. Well, thanks so much.